Welcome to episode 2.1 of our Pharmacy Calculations practice series. This is in response to some good criticism we got about the last episode where we solved a problem using cross multiplication when we could have used alligation. And at the time, I thought we were trying to be consistent with our methods, but one of our students pointed out that the question could be solved a little simpler using alligation, so we thought we'd revisit this question and show how to solve it using that method. So the question gives you a scenario where you need to make a 1 liter bag of 0.9% sodium chloride solution or normal saline using a stock vial of 23.4% sodium chloride. And the question specifically asks you how much sterile water is needed. So that's what we need to answer here. But we can get there by setting up an alligation. And anytime you're going to use alligation, you're going to draw a diagram that looks like tic-tac-toe. And in the top left, you're going to put the larger concentration, 23.4. In the bottom left, you're going to put the lower concentration. And in this case, sterile water is actually 0% sodium chloride. In the middle, we're going to put our desired concentration, which is 0.9%. And we're going to complete this by taking the larger concentration down here to the bottom right. It's going to be larger concentration subtracting your desired concentration. So 23.4 minus 0.9 is 22.5. And then we're going to take our lower concentration and take it up to the upper right hand by taking our desired concentration and subtracting the lower. So we're going to be left with 0.9 there. And these two numbers are going to give us our ratio, or the proportion of the larger concentration across to the proportion of the lower concentration. So we're going to have 0.9 parts of the 23.4% for every 22.5 parts of the of the 0%. Now we can solve the question of how much sterile water is needed by starting with the total volume that we're going to need, which is 1 liter. We'll go ahead and convert that to 1,000 milliliters to make this a little easier to look at. So it's going to be 1,000 milliliters. Now there's going to be a total of 0.9 plus 22.5. So there's a total of 23.4 parts here. So 0.9 of that 23.4 is going to be 23.4%, and then 22.5 of that 23.4 is going to be the sterile water. So then we can solve this by taking the 1,000 milliliters of our 0.9% that we need and multiplying that by this fraction here. This is the proportion of sterile water. So we'll multiply that by 22.5 over 23.4. And if we do that math, if you have a calculator handy, you can do 22.5 divided by 23.4 times 1,000, and your answer is going to be 961.5 milliliters, which you may round up, depending on which multiple choice answers you have available to you. And as you can see, this is just another way to solve this equation. Now you can go back to episode 2.0 if you want to see how to solve this by setting up a series of proportions to begin with. If there's anything you need help with or any specific calculation questions you'd like to see solved, please contact us. You can do so on our Facebook page listed here or via email at info@pharmacytechscholar.com.